Okay, so welcome to lecture 3 of this week 9, where we have a look at the stablecoin app. So in this lecture, we have a look at the Oracle contract, which you will find in this week 9 on-chain folder. So these are actually all the different components we have introduced. So in this week, we have a look at this oracle.py. And actually, so here we import from this comment file. So let's have a quick look what that is. So in this comment file, we just fix the stablecoin token name to this USDP. And yeah, this is to ensure that we will use the same one in both the Oracle and later in the collateral where we also import it. And then we define here the collateral datum type, and we have two functions to kind of parse the collateral datum and also the Oracle datum, which is just the integer representing the rate. And note that both of these use this unsafe thing, so this means if somehow the datum has not the expected format, then this just causes an error, which causes the validator to fail, which is actually what we want in this case, because then the transaction should not be valid. So going back to the Oracle contract, we have here the parameters. So the Oracle has two parameters. One is the NFT that kind of uniquely identifies it, and the other one is the pub key hash of the operator. So we want only this guy to be able to update the value, so to consume the UTXO and replace it with a new one. So then for the redeemer, we have kind of these two types corresponding to the two actions that we will need. And the first one is to update it. So this will be like consuming the current one and replacing the UTXO with a datum that has the new price. And the second one is that also if we want to kind of shut down the stablecoin, we have this delete option that kind of completely kills the UTXO and doesn't create a new updated one. So then let's go down here and look directly at the validator signature here. So first we have these parameters. So this is given at the compile time. So we fixed the parameters that we just saw. Then the next one, the rate, this is the datum, as we discussed. And then we have the redeemer, as we just saw, and as usual, the script context. So then we have the two cases here, the update and the delete case. Let's first look at the update case. So in this case, what do we do? So first of all, we extract from the context this so-called own output. So this is just the output that goes back to this script's address itself. So remember, if you want to update it, we kind of want that there will be like an output that is kind of the updated one and that still has this NFT and so on. So this we call the onTXOut. And then we want to ensure two things. So first of all, this identifying NFT should be both in the input and it should also be in the output. So here we check that input has this token that is hard-coded in the parameters, and that the output has it as well. And the output here is exactly this own output, not some other output that maybe goes to some random address. Then, as we discussed before, we want to make sure that only the operator can actually update the UTXO. So here we just check that the operator has signed it, and the operator is kind of given here in the parameters. And then we have a check for the output datum, and this kind of just ensures that this output has at least the valid form, so that, yeah, in case the operator somehow messes up the format, then the transaction will also be invalid. So let's quickly have a look at each of these functions as well. So here, this kind of thing that ensures that the input has a certain token. So here we just get this this tx out that is like the own input. So we kind of can extract from the context the output that basically goes to the address that is kind of given in the purpose, which is the script address itself. And then we check that kind of this sort of own input has in its value exactly this NFT token with policy ID and token name defined in the parameters. Okay, and we want exactly one, not less and not more. Then we also do a similar check for the output. So here we already give the transaction output, and we check that again in its value. If we look up, basically remember the value is like a dictionary of policy ID and token names. So if we look up under the right policy ID of this NFT and the token name, we want to have exactly one of them. Then we have this check operator signature. So this is kind of a simple thing we've seen before. We just take the operator from the oracle and check that it is one of the signatures that is given as list in the TX info from the context. And then for this output datum check, basically we use this parse oracle datum function that we saw before in here. That kind of just ensures that at least the datum has the right type here. And this would fail in case it's the wrong type, and then cause this assertion to fail. Okay, and then we have the other case of not updating but deleting. And in this case, we don't, of course, we cannot do this input and output checks because there will be no output. And also there's no datum then in that case. So yeah, we simply allow the operator to basically not create an output. And in this case, all we really check is that the operator has signed it, because the operator is, in this case, is kind of a trusted entity. To kind of zoom out, the whole Oracle validator basically boils down to kind of this. I mean, in some sense, we trust the operator to update it with the correct price, right? So there's no way we can validate this on chain, but we do certain kind of sanity checks on chain, let's say, and that is that at least sort of the Oracle is not used in a wrong way, let's say, like the NFT comes in, the right NFT goes out, and the datum has the correct format. And yeah, and the rest basically we rely on the operator signature. And then just a note about the next video. So in the Plutus Pioneer program, there's another video about off-chain code now, to see how in this Lucid framework one can update and delete the Oracle. And this is shown in lecture 3 of the Plutus Pioneer program. And we're not going to cover this here, but we're going to jump straight to lecture 5, where we're going to discuss kind of the heart of the dApp, which is the minting policy for the stablecoin. Thanks, and see you.